Okay, so you're still with me after nwise and nwise longest. Here's a question. How on earth do these help us solve any real problem in our real lives? Well, I want to show you something that I really like about this approach for Python programming, this approach using iteration helpers. One of the things that we know when we're writing Python code is we want to expose the thought process that we have when we're trying to solve the underlying business problem to the readers of our code. We want to minimize how much mechanics they have to wade through to actually get to the interesting thing. And we want to, as a consequence, minimize some of the administration that shows up in our loop code, these lines of code that just control how we do the loop, but don't really give a sense for how we want to go about thinking about this underlying problem. And this is something that comes up quite a bit when we're processing data. Think about it. You have some large data set. You want to process it. You want to do something special for the first element. You want to do something special for the last element. And you want to look at a little bit into the future and a little bit into the past. For example, you have some measurements and you want to figure out what are the differences in those measurements. You want to print out a report. So you have some set of measurements here. And I'll just simulate these measurements with some random data. And I'll call these measurements MS for short. And let's say we have a measurement here, maybe 5 measurements, A, B, C, D, and E. And what we want to do is we want to print out a report. And as part of this report, we want to print something special, like where this entire measurement process started, where it ended, and what the pairwise differences were. We can do this in a number of different ways. And I'm sure you've all written code of the form like this. Let's say here are our measurements, maybe dump these items into a list. And once you dump them into a list, then you can get the first element. So the first element would be like that, and this would be the first element and the first value. And the last element and the last value could be constructed in the same fashion. We can print these out to the screen. So the first element, here we print that there. And here's the last element, and here that gives us our starting point. And our stopping point or our ending point. And I'm sure you've all seen some code like this. And you can see, as we look at this code, it's going to become very mechanical. You might have said, oh, you know what, I need some previous state. So I can say, here's the previous element and the previous value, and that's set to none, some sentinel, and then I'm going to loop over my elements. So here I'm going to loop over the current element and the current value from my structure like this, and I'm going to say if the sentinel is still set, then that means that I'm at the very first beginning of my loop, and so that indicates that I need to capture some of the state, so I have to do something like this, current element, current value, something like this, and I'm already getting sleepy writing this code like that, and we have to actually also put this down here, and now we have our pairwise, so we can say from the previous element to the current element gives us a difference of whatever the current value is minus the previous value. And here we have our nice little report. It started at some point. You can see those are the differences between each of the steps from A to B, B to C, C to D, D to E. And it's very mechanical. And somebody reading through this code can see the mechanical process by which you computed and generated this report. But that is not what constitutes really readable, really nice Python code. Really readable, really nice Python code allows you to see what they were thinking about the way in which they wanted to solve the problem, separate from the mechanical steps they took. And so rather than all of this administration, where you can see all of this is administrative code, setting up how we do the loop. This is administrative code here. This is administrative code here. This is administrative code here. This for loop just represents the mechanical process by which we go through the elements. Instead of all of this nonsense, we could do something like this. We could say, take my elements in pairs and directly loop over the previous element, the previous value, and the current element, and the current value in this structure. And we'll take the same printout as before to show you that we're going to generate code that does the same general idea. So there you go. And when you look at that code, you can actually kind of make heads or tails of what that it's doing. Oh, you're looking at the previous element, the previous value, the current element, the current value from my data structure in n-wise pairs in windows of some size. And I could be more explicit here. I could call this pairwise, or I could say n-wise, n equals 2. But you can see that I've reduced the amount of administration that shows up in this code. And this for loop is now beginning to have meaning. And it's beginning to have meaning beyond just, oh, I have a bunch of data items, do this one, do this one, do this one, do this one. Instead, what it means is I have some data and I want to go through that data piece by piece. A very subtle difference, but a difference nevertheless. Well, I know I want to do something different at the very first iteration and the very last iteration. So now I could say, you know what? Do this. Give me the elements from the structure in pairs, notating the first. And if we're at the first, then do something special, like print out our special print statement here. And similarly, if we're at the last, oh, and we should change this here as well. So this means previous value, and this should be previous element. And if we're at the last, do the same general idea. So do something like this. Now this header line is getting a little bit long, and you might say, well, you know what, maybe this is a good choice for a helper function. Maybe instead of saying is first, is last, previous element, and so forth and so on, where this thing gets long enough that it scrolls off and wraps down, yeah, maybe there's some benefit here. But what I want to show you is the following. When I rewrite the code in this fashion, it's not just a party trick. It's not just about jamming as much as I can in one line. It's not just about figuring out if I can come up with a motivation for things like n-wise and n-wise longest. It is instead a desire to take this code and to lay bare the thought processes behind what I was trying to accomplish while minimizing how much mechanics somebody is exposed to. Think about this. In the very first version, we had this looping. And this looping was a mechanical thing. It was mechanically visit each element, and you do something special if you're at the very beginning because you have to set up your state of the previous element. In this version, the looping metaphorically represents something. It represents that this analysis visits every element. It metaphorically represents that it does something special. And you can see it visually. You do something special when you visit the first element. You do something special when you visit the last element. This is why I am such a big believer in the itertools module and these kind of helpers, because it allows me to take an idea of how I process some data and to express it to somebody in a way where, if I'm successful, the basic Python syntax, the basic Python mechanics start to be imbued with more meaning to the reader. You can look at this code and say, okay, what the heck is going on? Yeah, it's a little bit hairy in that top line, but the general idea is I'm looping through the data in pairs, notating the first elements and the last elements. If I'm at the first element, do something special. Otherwise, do something for all of the elements. Otherwise, do something special if I'm at the last element. And the general motivation or general thought process for how I was going about solving this problem is visible, with the mechanics for how I went about computing it still there, but separated off into the iteration helpers. This is where n-wise and n-wise longest can have real value in your life and in your work.